8E, we're going to look at polynomial models in the real world. So we did, way back in Unit 4, we did quadratic models and using the calculator to find the equation. So now we're going to do it with all different kinds of polynomials. Alright, so the calculator steps, the first thing you're going to do is go to Menu and then Stat. Alright, and you're going to enter your data in that list, and then it is F2 calc, F3 regression, okay, and then you have to pick the kind of regression that you're doing. So if it's linear, it's x. If it's quadratic, it's x squared. If it's cubic, it's x to the third. If it's quartic, it's x to the fourth. So you have to pay attention to what the question's asking and pick the right kind of regression for whatever the problem tells you to do. Okay. So when you first, if you don't know which kind, okay, you're going to plot the data and look at the plot. So instead of choosing regression, you would choose graph and graph 1. And of course, mine's not going to work because I don't have any numbers in there, but it would show you a plot of the points like this. And so you're just looking at the general shape. Okay, and you need to know kind of the general shape of these 4 graphs. Now remember, they can be transformed. So like I could flip this graph upside down and it might look like that, or it might get really skinny, or it might get really wide. But it's all that general U shape, and so if we have those, we would use a quadratic model. If it makes this kind of squiggly, remember, like same thing, it could get really skinny or it could flip the other way, but it's all that little squiggly shape would be a cubic model. This is a quartic model, okay, same thing, this could go kind of the other direction. Alright, so we're just looking at the general shape. If the problem doesn't tell you, then that would be how you would choose which kind of model to use. And the way that we can decide the best one is to look at the r squared value. So remember, when you actually get the equation, it gives you the equation and it says r squared. And so remember we talked about in Algebra 1 the correlation coefficient and wanting that to be as close to 1 or -1 as possible. So we're going to look at the r squared, and we want the one that is closest to +1. So like let's look at these examples. So they are going to ask you to do a cubic and a quartic model and explain why one models the data better. Well, the better model is going to be the r squared value that is closest to 1. So I'm going to put these numbers in the calculator in stat. Alright, so there they are in my calculator, and I'm going to do calc, regression, reg, and they want to choose between a cubic model and a quartic model. So cubic would be x to the third. Alright, and so when I do that, x squared is 0.997. Alright, then I'm going to go back, so I'm going to press exit, and this time I'm going to choose a quartic model. And there, my r squared is +1 exactly on the dot. So that means the quartic model is the better one, okay? It models the data better. So I would write that equation, and if you forget, you can always scroll down and it tells you. So ax to the fourth plus bx to the third plus cx squared plus dx plus e, and then up there it gives you a, b, c, d, and e, that you would write down that equation. So we're looking for the r squared that is as close as possible to +1. Alright, so here's our next example. Which is a better fit, quadratic or cubic? Alright, so quadratic, remember, is x squared. Cubic is x to the third. So we're going to put these in the calculator and look at that. Alright, so I got my numbers in, and so let's look at the quadratic. So x squared. Alright, and my r squared is 0.759. So then I'm going to go back, and I'm going to choose the cubic model. And that time my r squared is 0.962, so that's much closer to 1, and so that is the model that I'm going to use. Alright, we're going to write the equation, so cubic is the winner. Alright, r squared is closer to 1. Write the equation of the model, so I'm going to round all of this to 3 decimal places, so y equals -1.167 x to the third minus 1.786 x squared plus 5.667x. And then last one, d plus 3.371. All right, plus 3.371. Okay, use the model to find the y value when x equals 5. I could just plug it in and do the math, or remember we can use the graph. And what I would recommend doing is pressing this copy button. So if I press F6, and then it's going to take me to the graphs, and I want the first one, so I'm just going to press enter on that y1. What that has done is copied this equation into the graph for me. So if I go to menu and go to graph, see, it copied the equation for me, so now I don't have to worry about typing it in there. Okay, so now I have it in there and I can see it on my graph, and I want to know the y value when x equals 5. So I'm going to do gsolve and go over. Okay, and we have ycal and xcal. I'm looking for a y value, so I'm going to pick that. It asks me for the x value. I'm going to put in 5. And it tells me that when x is 5, y is 158.771. So 158.771. Okay, and then the last part, use the model to find the x values when y equals 3. So again, gsolve, go over. This time I'm going to do xcal, and my y value is 3. All right, so right there, when y is 3, x is negative 3.076. All right, negative 3.076. And remember, there can be more than one, so I'm going to scoot over. Over here, it's 0.064. All right, so 0.064. And it looked to me like there's one more place where y would equal 3. All right, so that would be 1.609, but that's going to round up, so 1.61. All right, so there are 3 places there where y equals 3, and I can get them all using my graphing part on my calculator.